Hello and welcome everybody to our second video of Unit 2 on Logic and Reasoning. We're taking a look at statements and conditionals today. It can be found on page 119 and 130 in your text, or we can find it in the note sheet which you're filling out right now. So write and determine the truth values of compound statements is what's going to be taken care of in this video, hence highlighted by that arrow. And in the second video, we're going to write and determine the truth values of conditional statements. So the two videos are going to be split in half. The second one might be a little bit longer because there's a lot more notes that go with it. This first one deals with two things, a disjunction and a conjunction. We're going to start by looking at a disjunction. So a disjunction is when you have a compound statement or a statement made up of two or more statements using the word or. Only one statement has to be true for the compound statement to be true. So we look in that truth table there on the right, P represents our first statement, Q represents the second statement. It's saying, and this upside down V is a symbol that is utilized to represent or in terms of combining a statement. You can have another one that says P or Q or W if you wanted to, but we're only comparing two right now, so there's only just one symbol. So we're saying if they're both true, obviously the entire statement is true. If one statement is false, it's still true in these two scenarios. The only scenario when a disjunction is not true is whenever both statements are false. And you can see that again evident in this diagram. That the middle represents when they're both true. The outer part for each of them represents when that's only true for one of them. And then the outside represents false statements where neither of them are false. Or I'm sorry, neither of them are true. So let's look at an example to kind of further that idea. Mr. D'Amico teaches geometry or SciTech is in Oakland. So if we're thinking about both of those statements, Mr. D'Amico teaches in geometry is definitely true, hence why I'm making this video for you. SciTech is in Oakland, clearly, and again, some people after that activity we talked about there being a SciTech in New York as well and in most major cities, but the one we're referring to is definitely in Oakland. So therefore, this is a true disjunction. Both statements are true, therefore the compound statement is also true. And there is our little truth value to kind of help us out, or truth table, I'm sorry. Second one is the number 4 is odd, already raising red flags for me, or 57 is a prime number. So 4 we can clearly agree it is not odd, it's absolutely even. And 57 is kind of tricky in terms of being prime, but it's actually composite because it's 19 times 3 is 57, which means it has more than one factor, or more than one pair of factors other than one in itself. So therefore, this statement is false. Since both statements are false, the entire thing is false. So if one of those would have been true, the disjunction would have still worked. So again, if they're both true, it's true for a disjunction. Or if there's only one that's true, it's also true for a disjunction. Only scenario where it's not true is when both statements are false. That's not entirely the case for a conjunction. So we look at conjunction notes moving down the page. You can see a compound statement using the word and is the definition of a conjunction. So if you hadn't already guessed, the first one was or, the next one was going to be and. And that's when both statements have to be true for the statement to be true. So for the compound statement to be true itself, we need both. And you can see in the truth table, there's only one scenario when they're both true. Unlike disjunction, it's almost the exact opposite. All of these scenarios are going to be false. So only one is true when they're both true. Every other scenario is going to be false. And that's evident again in this Venn diagram where the middle is filled in as in being true. So when both statements are true, the entire compound statement is also true. All right, let's look at some examples for that to kind of further that idea even more. Math is a 4-letter word and third period starts at 8:55. Again, referring to 8:55 at SciTech. So math is a 4-letter word. We can agree if you count them as obviously 4. And we know third period now starts at 8:55. It used to start at 9:01. So this first one is definitely true because both of them are true. And I didn't mention it in the last slide, but if you look, it's the exact opposite of an or statement, the symbol for and. It's an upside down V or a giant caret. If you look on your keyboard, the number 6 is a caret. It's just a giant version of that. All right, one more example here. George Washington was the first president of the United States, and the United States capital currently is Philadelphia. As much as you might not be a Philly fan, being from Pittsburgh, Philly is still not the capital, and you can see that George Washington is, or was, the first president. So this is a false statement because only one of those, the George Washington statement, is true, And the United States Capitol statement is obviously false. It's in Washington, D.C. Fun fact, though, it was originally housed in Philly before they moved that many, many years ago. So again, both have to be true for it to be true. Every other scenario of a conjunction is false. Make sure you go back if you need anything else in this video to peruse, and make sure you fill in the Venn diagram and any words that go with it, as well as completing the truth value of each of these statements. All right, everybody. Thanks so much. I'll see you in the next video on conditional statements.